Today we will calculate the discharge and velocity by using the Bernoulli's equation. So there is one problem which we are facing to solve it. Water is flowing through a tapered pipe having the diameter. So D1 is given here as a 300 mm. D2 is given here as a 150 mm. At a section land at section 1 and 2 respectively, the discharge through the pipe is, so Q is given here as a 40 liter per second. Section 1 is 10 meter above the datum, so Z1 value they have given as a 10 meter, and section 2 is 6 meter above the datum, so that is Z2 value they have given as a 6 meter. Find the intensity of pressure at section 2, so we have to calculate the value of P2, and if that at the section 1 is, so P1 value they have given as a 400 kilonewton per meter square. So this data they have given, and based on this we have to calculate the pressure. So first of all we will draw the diagram of this. So there are the two pipes at section 1 and at section 2. Section 1 and section 2, if we say this is the diameter of the pipe, we can say this section is a 1 it is called as a 1 it's section number 2 it is there. So for section number 1 diameter they have given as a 300 mm. For section 2 to D2 they have given as a 150 mm, and whatever the value of datum they have given, so that datum value, from the datum that Z1 and Z2 reflects. So Z1 value they have given as a 10 meter, and if we calculate the value of Z2, so that Z2 value they have given as a 6 meter. So from this we have to calculate the pressure value, that is the at section number 2, that is P. So we know the Bernoulli's equation, that Bernoulli's equation, or Bernoulli's we can say that Bernoulli's theorem, which is I am writing here, that is P1 upon gamma plus V1 square upon 2G plus Z1 equal to P2 upon gamma plus V2 square upon 2G plus Z2. So this is the Bernoulli's theorem, where P1 is the pressure at section number 1, gamma is the density of water, velocity V1 is the velocity at the section 1, Z1 is the datum value at section 1, P2 is the pressure at the section number 2, V2 is the velocity at section 2, and Z2 is the value of datum at the section number 2. So already we know, we don't know the value of velocity. So for that we have to calculate the velocity, and for that we have to use the continuity equation. So what is that continuity equation? So continuity equation is nothing but discharge equal to A1 V1, means discharge throughout the section which will be same. So if we see discharge is Q, so in that case velocity V1, V2, A1, A2 which are going to be changed, but whatever the total discharge it will be same throughout the section. So that's why Q equal to A1 V1, Q equal to A2 V2, that we can put. So for that first we should know what is the value of area, what is the value of A1 and A2. So A1, the pipes are circular pipes, so pi by 4 into D1 square, so that is the area of the pipe number 1. So pi by 4 into d square, so we will write in terms of the meter. So what is the value? 0.0707 meter square. So that will be here as a calculation part, 0.3 into 0.3, so that is 9 by 100 into 3.14 equal to divided by 4. So the answer is the correct one, that is the 0.0707. So in same way we will calculate the A2 value, pi by 4 into D2 square. So that will be here as 0.07065. So we will write 0.0707 pi by 4. From that 3.14 divided by 4 into diameter D2 they have given as a 0.15 bracket square. So from that again we will calculate the value, 3.14 divided by 4, that is the pi by 4 into 0.15 into 0.15. So what will be the value? So that is 0.017. 0.01766. So these are the values of A1, A2 in terms of the meter square. Later on we calculate the discharge, that Q equal to A1 V1 already we know, Q equal to A2 V2 already we know. So Q already we know that they have given as a 40 liter per second. So Q value is the 40 liter per second. So we'll convert it in terms of the meter cube per second. So how to calculate it? 40 divided by 1000. From that we'll get the value in terms of the meter cube per second. So that is the 0.04 meter cube per second. So now we'll calculate value of V1. 0.04 equal to A1 value already we know, so that we have calculated here as a 0.07007 into V1, and same way we can calculate here again V2, that is 0.04 equal to what is the value of A2? A2 is 0.01766 into V2. So in same way we can calculate as a V1, we can calculate as a V2. So what is the value of V1? So V1 will get, that is here as a 0.04 divided by 0.0707. So from that the value will get as a 0.5657 meter per second, that is V1 value, and V2 value will get, that is 0.04 divided by 0.01766, and that value will get as a 2.26 meter per second. So from now we know the value of V1, we know the value of V2. Again we know the value of P1, that P1 value they have given as a 400 kilonewton per meter square. So we have to calculate the value of P2. So we'll apply the Bernoulli's equation. So Bernoulli's equation. So by applying this, P1 upon gamma plus V1 square upon 2G plus Z1 equal to P2 upon gamma plus V2 square upon 2G plus Z2. So P1 already we know, that is here as a 400. Gamma value of water, density of water is 9.81. P1 value already we know, that is 0.5657 bracket square as per the formula, divided by 9.81 plus Z1 value already we know, they have given as a 10 meter. So that will write here as a 10 equal to P2 we have to calculate, divided by 9.81 plus V2 value already we know, that is 2.86 bracket square divided by 2 into 9.81 plus Z2 value, that datum value they have given as a 6 meter, that will write. So we know already the unknown value is here as only the value of P2. So from this basic calculation we'll get the value of P2, that is here as a 436.84 kilonewton per meter square. So this is the value of pressure P at section number 22, that is P2 value as 436.84. So in that way we have solved this problem to calculate the pressure intensity at the section number 22. Thank you all of you.